a sentinel. Um, well, a sentinel is basically a value in a sequence that marks the end of that sequence. Like in a, if we are asking in this example also, we are asking the user enter the numbers. But in this point, we are assuming that we know that we need 10 numbers. But in many cases, it might not be the case. Let's say that I'll just get the numbers from the, or maybe I'm like an accountant software, okay? So we want to keep the number of items sold in a month, and then maybe we will calculate the total amount of sale and maybe the average or so on. But the thing is, we don't know if it is 10 or 15 or 100, so we have no idea. Then, but the user should keep entering that, and then we will calculate their summation. Then how can we know that, okay, we reach at the end? So for that one, we can say that, okay, no price of an item, n price, should not be any negative value. It shouldn't be -1. It should be greater than some value, greater than 0. So then we will ask user, we can ask, say, okay, provide us the number of sales, and then maybe he will start inputting, giving us the numbers. But then we will say, okay, whenever you are done, give us -1, so that we will understand that, okay, now we reach at the end of the sequence, and we will not get any more numbers. So for those numbers, we call it is sentinel. So it doesn't have to be -1. Of course, you can say that, like, okay, -1 is a valid, I mean, it is a reasonable number, but you could say any number less than 0. Or maybe you are getting student names in Arabic, and then maybe we'll say that, okay, when you are done, write in English any word, any letter, or write done, okay, a word that will not be a student name. So that is also a sentinel number. So any value that represents that we reach to the end of the sequence values. Here is an example. Again, I will just go to the previous part that we had done in the last lecture. In that one, we were asking that, okay, 10 times. So our condition was that is count less than 10 or not. But in this example now, we don't know how many numbers it will provide. But what we are saying is, so again, we keep the start total from 0. And then we ask the user to input some numbers. But then we say that, okay, -1 to quit. Okay? So in our while loop then, now we are not saying that if the counter is less than 10 or so, we are saying that is this points, which is the input value that we got from the user, is it -1 or not? If it is not -1, it means that, okay, the user is still providing us some valid numbers, so we will keep adding it to our total score, and then we will ask it again. Is it -1? If it is not, ask it, do the summation, and then ask it again until the user give us a -1 value. Then what will happen is, if points is -1, -1 is not equal to -1, which is false, because it is so that we will exit from the while loop, and then we will print the total points. So here is an example. Like the user, let's say, assume that he entered 12, then 22, then 4, then 54, then -1. So then we print the total points, which is 92, like 12 plus 22, 34, 38, and then 92. Well, of course, it doesn't have to be like 4 numbers. Maybe in the beginning we ask again, he entered 67, and then -1. So okay, then we'll say, okay, it's -1. We ended. It was just one number. So, but it allows us to do operations when we don't know how many exact numbers we should collect. So this is called sentinels. I would like you to memorize this term. Okay, maybe in the quiz or so, in the midterm we might ask also, like, write a sentinel value or something. Then you should know that, okay, what does sentinel mean? It means that basically a value that represents the end of a sequence. Do you have any questions so far? All right, I would like to start the for loop. This part is the important part. So far we have seen while loop, but in Python we have also another loop structure, another repetition structure, which is called for loop. So what is this for loop? Well, for loop is used for count controlled loop. So what does it mean? Well, if we know that, okay, I want to do this step for 10 times, for 15 times or so, then for loop is usually used. So it's not like in the while loop I was giving this example that we have a robot, and then in a while loop we were saying move forward while or until there is no obstacle. So for those cases we can use a condition. We use condition, and while is a condition based loop. But in a for loop we will say do this 10 times, do this 50 times, and so on. You might say, okay, we were also able to do it in the while loop, like as we did here. Here also we were able to do it in the while loop. And yes, you are right. We can also use while loop with this structure to say that, okay, do it 10 times. But in a for loop, I'll say that you need less number of code to do the same thing with a for loop. And also for loops has one important structure, which is it is designed to work with sequence of data. I will talk about it later on, but its main functionality is that we are assuming that we have a sequence of data. What is a sequence of data? Let's say that we have a class and there are students. So each student has a score, let's say GPA, and then we want to calculate the current total GPA. So I would like to go iterate over the students. Like for each student, I would like to do this particular action. Like maybe I would like to calculate your letter grade, and I need to do it for all students in the class. Then for loop sounds reasonable one. For each student in the class, do these operations. So this is what I would like to tell to the computer. For those cases, we use for loop, and it has this syntax. For is our keyword. This variable written in green, it can be any name. It is user-defined variable name, and then in is also a reserved word. We say that keyword, and then we have these square brackets. So now this is a very hard notation. A square brackets in Python means it is a list. It is a sequence of data, okay? And then between those square brackets, I put my data, val1, val2, and so on and so. And then here again we have this double column, and then we write the statements, but again we need to pay attention to the indentation so that we know that those statements with the indentation belongs to the for loop. Then how can I translate this to English? Actually what I'm saying is for each variable in this list, do these actions. So going back to my analogy, my example, let's say that we have these students, okay? So my list is students, student 1, student 2, student 3. And then I will say, for each student, and I'll call that student variable in this example, for each student in this list, calculate their letter grade. And here is one example that shows. So when you look at this code, well, with an educated guess, even though you don't know how for loop looks, probably you'll guess that, okay, it should print 1, 2, 3, 4, 5. But I would like to go over that, how it is actually executed in detail, okay? So when we write this code, for num in 1, 2, 3, 4, 5, and then with a print num. So what is happening is, so the computer starts, and then, well, we check, okay, are we done? Are there still some more items in our list that we didn't process yet? No. Okay, then pick one item from that list, and then do our statements, which is, in this case, it is printing, and then check it again. And then are we done? Are there still some elements? No, we still have some elements to process. Okay, then pick another one and do our operations until we process all the items in our list. So in this example now, what is happening is, please follow my mouse handle here. So in the very first iteration, we pick the first item in our list, which is 1. And then we assign that value to our variable name num here. So I'm going back to this slide. So I said that this is a user defined. I can give any name. So this is variable. So for this example, I said that num. And then, so I assigned 1 to num. And then I print this variable num, which will print 1. Then I'll go to the next iteration, in which, so we have still 4 more items. So we pick the next one, which is 2. I will assign it to the num. Then I will print num. Then I will go to the other, pick the other item, 3. I will assign it to the num, print num. I will move to the other one, which is 4. I will assign num. I will assign 4 to num, and then print num again, print 4, and then in the last iteration, I will assign num to 5, and then I will print 5. Once we are done with all these items, now there's no more in item, we will exit from the while loop, from the for loop. Sorry. So let's do an example in our Python code. So it will be a little bit slower. So what we will do is, for is our keyword, and then we need to define any variable name. So you can call it x, you can call it num, variable, whatever name you would like. And then in is also another keyword. That's why it is written in blue. Then I need to define my list sequence. So it can be, it doesn't have to be in order. Like it doesn't have to be 1, 2, 3, 4, 5. Maybe it's not ordered. Maybe it has some duplicates, as you can see here. And then some double column. Then, well, I can do any actions, like let's say we might want to print it, maybe, or maybe I just want to calculate the summation of these numbers. So I will do a very similar thing that we did with the while loop. So I will calculate the total to 0. Then at each iteration, I will say total. I will add this x to this print I will add this x to the total, and then I'm done. And then maybe at the very end I will print total also. Okay. So, and just to make it more readable, I'll also put this total message here. All right. When I run this code now, what will happen is basically at each iteration it prints 1, 2, 4, 1, 3, 51, 52, which is actually exactly these numbers. And then at the very end it also prints 114. What is that? Well, it is basically the summation of these numbers. 1 plus 2, 3, plus 4, 7, 8, 11, and then 11 plus 130. These two is 103. So it is 114 in total. So basically what we did is, at each iteration, the value of this x becomes one of the items in our list, starting from this. So in first iteration, it is 1. In the other one, it is 2. In the other one, it is 4. In the next one, it is 1 also. So it doesn't have to be order like 1, 2, 3, 4, 5. It can be in any order. Well, maybe, I'm just now making up, maybe you want to just print numbers in descending order. So if you would like to do it, we can also do it in this way. So it's 532 to 1. So it will print from 5 to 1. And also, now going back to my example, it doesn't also even have to be numbers. It's just a sequence, like of any data. So in a sequence, let's say that I'm keeping my friend's name. Again, between these square brackets, I put my friend's name, well, Joseph, Glenn, Sally, so whatever. Then again, in a for loop, for friend in friends. How can I translate it to English? Well, for each friend in friends list, do this action, which is print Happy New Year, and the friend will be, in one iteration, it will be Joseph, the other one it will be Glenn, in the other one it will be Sally. Once we are done with all these items in my list, I'll just print done. So what you can notice is that I don't need to write these square brackets here. I can also define it as a variable like this here, and then I can just put this variable here so that it might make it more readable. Do you have any question? Shall I proceed? So when we can actually do many things with these for loops also. Now let's start like, how can we find a largest value in a list, in a given list? So we need an algorithm for this first. Then it's so easy to translate it to Python. Now let me ask you this. If I give you a really long number, like, let me write it also here. I'm just putting here some random numbers. Okay, maybe it's hard to read and so on. And then it can move on. When I ask, okay, which number is the greatest one? Please go, you can go over the numbers. Great. Now I ask you, how did you find it? So whenever we are trying to develop an algorithm, actually we need to think about, okay, how did we come up with this solution? Because then we will apply that, we will tell it to the computer. That will be actually our algorithm. And the good thing with the programming is that, like, when I ask this question, probably, I mean, many people actually do not think it like, okay, I did solve it in this way. It's just like, I look at it and then find it. But actually, the computer will not work it in this way. But now let me ask you, okay, how did you find that it is 546? What was your algorithm manually? Well, this is important because I have given only some numbers you can read here, but what would happen if there were 1 million numbers? How would you find it? Any volunteer to share their thought process about, okay, I found this maximum number like this. What do you do?
Compare each number to the second number in the list?
Yes, we do the comparison, but in more detail, actually, we do more than that. But yeah, this is one part of it. So the good thing with the programming courses is that the goal is like, learning Python is of course one contribution, but actually learning programming is really transforming experience. Like, it transforms, it changes the way you think. It makes you a person who gives more rational decisions. The reason is that we always, when we write a code, we first ask ourselves, okay, how can I solve it? Or how do I solve this question? And then we break it down. Okay, I give this decision like this. So if I give you 1 million numbers, you would still be doing that. But how would you do it? Well, without writing any code. Like, how did you find 546? I have to check all the numbers first. I mean, that's for sure. I need to check all the numbers in the list. And then I will say, okay, 1, and probably when I'm reading the numbers, what I will do is, okay, 1 is the greatest number that I have seen so far. Then I'm moving to the second one. 3, okay, I'll just now doing this comparison that you mentioned. 3 is greater than 1, okay. 3 is the largest number that I'm seeing so far. 5, okay, 5 is greater than 3, so I can now forget 3. Okay, 5 is the greatest one. 2 is not greater than 5, so skip that. 5, still same, so I can go with this. 5 is, okay, 34 is greater than 5. Okay, then I don't need to keep 5 in my memory. This is the part what I'm saying. Okay, 34 is now my greatest number. I will keep moving on. 543, it is greater. Then I will remove 34, and then I will keep 543. Then 546. Then 5, no, it's not. 54, no, it's not. It's not greater than 546. And then when I go over that, none of them will be, but I'm checking all of them actually, and saying, okay, none of them is greater than 546, so that this is the largest one. This is our actually intrinsic algorithm. We go over all the items, and then in our head, we always keep only the largest one. Like, I don't need to keep like, okay, 546 is the largest one, but the second largest previously 543. No, I'm not keeping it. I cannot keep it because the thing is, let's say that I give you 1 million numbers. How would you, like, I don't need to keep all the previous largest numbers that I have seen so far. I just keep the largest number that I have seen. So this is the way I think. So then, okay, then now I will just translate this thought process into Python. How do I do it? Well, let's say that we are collecting scores. So I know that it cannot be less than 0, okay? So this is my starting point. Let's say that largest number so far I have seen is -1, okay? Then this is my list that I would like to find the largest number. So for each number in this list, I will compare if the current number, the num, is greater than the largest number so far I have seen, then I will just update the largest so far variable with the current number. If it is not, so I will just skip it. That's it actually, this is the algorithm, but these print messages is just to track our execution. So let's look at it, how it will be executed. So before it is -1. Then we start with this part. -1, 9 is greater than -1. So then I should update my largest so far. So I will print 9 and 9. Then I will go to the second number is the current number. This is the largest number. The last one is the largest number. So 41 is greater than 9. So okay, I need to update my largest so far, 41. 12, it's not larger than 41, so I will skip it. 3, it's not. 74, yes it is. So I need to update largest so far variable, 74. And then 15, no it's not. I don't need to update it. So at the very end, it is 74. So what I did is, this was a very simple thought process, but I just break it down, like how I do it manually, and then I just translate it to Python. That's all I did. Do you have any questions so far? All right. Well, then I can use this for many different operations. Like, how can I calculate a running total, like we did in the Python example? Actually, I had also done it with my previous example with the for code. So how can I find the total value of these numbers? Again, I will start from 0 and keep it in this a total a variable. I will call this is the accumulator value. So this is a value that I need to accumulate. I will keep updating at each iteration. And then for each value in this list, I will edit this value to my total variable. I will update my total variable. And then this is just to track the code. So we print the total score and the current value. And then at the end we print the total. So here is the output. Again, the left part is the total, current total, and the value is the right part. The right output is the current number. So we start with 0, and we print 9. The total is 9. Then the current number is 41, and then the total score is 50. Current number is 12. Total is 62. Current number is 3. Total is 65. Current number is 74. The total is 139. The current number is 15, and the total is 154, and we finish. Shall I proceed? Or do you have any question? It's not a yes or no question. Please tell me something. No question? Okay. So now I would like you to pause and think about it now, like where we reached. In the beginning of the semester, like we were seeing many very basic stuff, like okay, assigning some values, printing some messages. And now we have seen if conditions, like if this is the case, then do this, if this is the case, do this. Then we just seen the repetition structures. But now what we are doing is, now we are combining all these things, and then now we are able to do many much more sophisticated things. So this is now the problems that we are able to solve actually now increased. It's not like anymore just print a message. If this is the case, print that, otherwise this, that. But now what we are doing is, okay, find the largest number, find their summation, average, and so on and so. So again, let's look at this this example. How can we find the average number? Well, what is an average? Total divided by the number of items. So first, I know how to find the total value scores from the previous slide, but I just need to add one more thing, which is once I find the total, I need to divide it by the number of items. So how can I know that how many items are there in the list? Well, I can also count it. Like I can assign one variable here to just, the goal of this variable is just to keep how many items are there in my list. This is it. So one of them keeps the total score. The other one is how many items are there in the list. So what I will do is, in each iteration, I will do this accumulating this sum variable. I will also increase this count variable by 1. So I process 1 item, 2 item, 3 item, 4 item, and so on and so on. So I will. So when I'm done with this for loop, this count variable will give me what? It will give me the number of items in that list. So what will I do with that value? Well, I will use it to count, to find the average, because I know the sum, I know how many numbers items are there in the list. So if I just divide it by that, then it will give me the average. So again, this is just to trace the code. We have those print messages. The left mode is the counter value. The one in the middle is the summation, and the rightmost is the value part. So again, we start from 9, count is 1, current value is none, summation is 9. Then we go to the second one, 41. So count is updated to 2, and then the total will be 50, and the current number is 41. Then the next item, the current is 12, so total is 62, and the count is 3, and so on. So it will go up to 6 items. So this is again a very common way. If you want to find, okay, how many items in a list, well, you can just count it. So by using just an additional variable. And the other one is like I would like to filter in a list. Maybe assume that this is the scores of the students, and I would like to find, or maybe the items list, the price list of an items, okay? And then you want to find that, okay, which items are have a value greater than 20 reals, okay? So I would like to print those and eliminate the others. How can I do it? Well, again, I will just go over my list for value in, and then my list, and then I will put an one if statement there, so which is if the current value is greater than 20. If it is greater than 20, print some message. So what will happen is this: when I do it, before we start, let me also show that, emphasize that. So I have one indentation for the for loop, and then but for the code that I want to run for the if statement, I'm putting some more indentation, because this print loop belongs to if statements. So if this is true, that should be on the run. So I don't put it there. So this is important. I just put some more indentation. And then how will we run it? Well, we first get, okay, 9. 9 is greater than 20. No, then skip it. 41 is greater than 20. So the condition is true. So we will print this large number 41. Then 12 is not greater than 20. 3, this will be false again. 74 is greater than 20. So we will run large number 74. 15, again 15 is not greater than 20. So we will skip it. So we will print only these two numbers. And now when we are now able to use repetition structures, branch, and then conditional statements, now we are able to do actually many things. Again, well, maybe I would like to find, okay, a search operation. Where can we use it? Well, maybe I have, in a list I have the student names, and I would like to know, okay, is this student in this list? Is she enrolled in this class? So I need to check it. I need to go over the student names and then check if the student is in the list or is in the class or not. How can I do it? Well, again, in this structure, well, this bit we can also write it actually. So let's say that we have a students list, okay. For simplicity and to gain some time, I will just give some ABC letters. Then I will check, okay, is this student my students list? I would like to check, okay, is there any student named or a code name, whatever it is, let's say C, okay? So how can I do it? Okay, if it is there, I will just check it. Is the name of the student, is that current one C or not? If it is, what will I do? Well, I can print it. Maybe I just say, I found it. Yes, there is. This is one way to do it. So when I run that code, it will just say to me found. But if maybe I'm looking for D, is that it? No, it's not, so it didn't enter anything. But maybe I would like to keep it in a different way. I don't want to print a message for it. I just want to say, is that student is in the class or not? So I would like to keep it like as a Boolean variable. Did I find it or not? That's it. I don't want to print a message. So what I will do is, if I found it, I will just change my variable to true. Otherwise, I will keep it false. And then at the end, when I'm done with this for loop, I can say that, okay, if found is true, which means, okay, the student is in the class, so then I can maybe print some message, whatever it is. Else it is not, then I will say no, it's not found, and so on. So this is also another way, like it depends on how would you want to do it. But the main idea is that, again, we are iterating over the items in my list, and then I'm checking if they meet my condition. If it is the case, then I'm doing what I would like to do, print a message or maybe setting a variable. All right. Do you have any questions so far? All right, so inshallah we will be able to finish topics. Now, when we are talking about this list, you might be confused. Okay, that is nice, but you might say, okay, if I want to print all these numbers, as you can see here, like this is not practical. Like, what if I had 1 million numbers, and then should I type them all in those square brackets and create a list? That would be like so hard to do. Like, instead of typing that, I would do it manually. That might be easier. And my code would not look nice. Like if I put all these large numbers, a very long list, because maybe I'm dealing with 1 million number. This is very reasonable. Like, let's say that in a social media platform, you are trying to find the most, I don't know, effective or the popular influencer. So you want to find the user who has the largest number of followers. Okay, so this is a problem of, so you have a list of people, users, you have a list of numbers actually, which represents the number of followers for each user, influencer, and then you have to go over them. Should we all type it or so? So this will, like, because current social media platforms, they have 1 billion users or so, or higher in some cases. So this is not practical. Of course, when we are, for those applications, they are getting that data from a database and so on. But the thing is, it's not practical to put them always in these square brackets. I need some, in many cases, I just want to do an action like 5 times. That's it. Then, so currently what we are doing is, I need a list 1, 2, 3, 4, 5, and then I need to do this action. Maybe this is one way to do it. If I do it, it will print it 5 times. That's nice. But what if I want to print it 1 million times? Should I put, again, some even more numbers here? Actually, this is, I can just add some more numbers to do it. Yes, it is, but it will make my code very not readable. I'm just putting some numbers and so on and so. If my goal is only to repeat an action a particular of times, Python has this nice function which generates me a list actually easily. Like, I want to do it 5 times. Okay, what I can do is, by using this range function, it will also do the same thing. It will print 5 times. Or I would like to do it, well, I would like to do it 100 times. Okay, then I just change 100, and then it will print 100 hello. So what is actually happening here is, it's not changing the way how for loop works. It is still iterating over the items. But this range function generates me a list. When I say 100, and then maybe then I can actually print those. Instead of printing hello, maybe I can print this X, okay? So what it does is, it basically, starting from 0 to 99. So when I say 100, 100 is not included, but it generates me a list of 100 items in that, starting from 0. So that I don't need to type 0, 1, 2, 3, 4, 5, 6 up to 99. I just say range 100, so that it will be executed. So this is one way, but you might say, okay, that's nice, but I need numbers not starting from 0 to 99. I need numbers from starting from 50 to 100, okay? Maybe your range, the numbers that you need is different. So what you can do is, then okay, I will just put 50 here. 50 and 100. Now what will happen is, basically, when I do it, it will start counting from 50 up to, again, my ending point, which is 99 at this point. So that's also nice. So now I can basically set my starting point and ending point, and then in between, this function will generate me a list, so that I can easily repeat some actions. That's also nice. But you might say, okay, that's good, but I don't want to have it only like one by one, because I don't need 51, I don't need 53, I just need even numbers. I want to work on even numbers. So I want to have 50, 52, 54, 56, and so on. So for some reason, whatever the task is, okay, then what you can do is add a third parameter here. I'll just say 2 here then, okay? Then what will happen is, it will print, again, starting from 50 up to 100. 100 is, again, not included. At each increment, at each step incremented by 2. So 50, 52, 53, 54, 56, 58, and so on, up to 98. 100 is not included. So I can generate all these numbers. Okay, then you might say, okay, that's also nice. Now I can also change how the value should be updated. What if I want numbers from 100 to 0? What should I do now? Now I'm actually able to do it. I just need to change the parameters of this range function. So from 100 to 0, so which means that I just need to change my starting point to 100 first. But if I just give one number, it means Python understands that it's from 0 to 100. This is not what I want. I want from 100 to 0. So my ending point is -1 or 0. Let's keep it to 1. I will, if you want to print 0, we should say -1, but that is fine. I will give that example also. But then now the thing is, if I start from 100 to 0, well, that doesn't make sense, because the default incrementing part is increasing. So if I do it, what it does is, here is what it does, what it did. Starting from 100, it checked, did we reach 100? Yeah, we already did. It's already greater, so we stopped. So if you don't want to do it, but if we do this in this way, I need to decrease it by 1. So then what will happen is, so at each iteration, how will I update it? I will not increase it. I would like to decrease it. So that's why I put -1. So when I run it again now I'm starting from 100. It goes all the way to 1. Why 1? Because we put 0 here. If you want to also print 0, well, then we should put here -1, so that this is our now ending point. And when we run it, now we also print 0. So in short, we don't need, in some cases, of course, you might need sequences, and we manually type it. But in most of the cases, we use this range function. If we just want to repeat an action a particular of times, we use range function. We don't need to manually type, create a list. In real life also, like, again, in most of the cases, we don't manually type all these lists. Like, how do you get the users from a social media platform? Like you get it from the database and then you automatically generate that list, so you don't need to also type it, of course. Is there anything that I miss? Let me check, please. No, good. Do you have any questions so far? All right, and so now with this turtle library that allows us to draw something, we can also we can use this for loop actually to draw some interesting figures. Like what we can do is like now, because now I'm able to say that okay, do this action this much of times. Like if I just move forward and then turn right, and then if I repeat this to 4 times, it will be a square. So, or if I go forward and then turn 45 degrees, and then if I do it 8 times, it will be that figure.